To integrate this problem here, we have an issue with this power on the cos. Okay, we cannot integrate cos functions with powers on them. So what we're going to have to do is we're going to have to use some trig identities to be able to get rid of that power. And so what we're going to do is use this identity, the double angle identity, 2 cos squared x minus 1 equals cos 2x. And we're going to rearrange that so that we can substitute for the cos squared and make it into cos 2x. So notice that there's no power on the cos 2x, which we can integrate. Okay, that 2 is a horizontal compression, and we can deal with those quite easily. So the first thing I've done is I've rewrote the cos 6x as cos squared x all to the power 3. And then I'm going to replace that cos squared x. That cos squared x is going to get replaced with that identity cos 2x plus 1 all over 2. And I'm going to cube out that expression. Okay, so let me just clean up those brackets a little bit. And I'm going to cube that expression. So when I cube that expression, I'm going to cube the 1/2. So I'm just going to take that outside here as 1 over 8. And then when I expand the cos 2x plus 1, I'm going to use a binomial cubic expansion. So the coefficients are 1, 3, 3, 1. So I end up with cosine cubed 2x plus 3 cosine squared 2x plus 3 cosine 2x. Well, I can integrate that part plus 1, and I can integrate that part as well. Okay, so I still have the cosine cubed 2x and cosine squared 2x that I have to deal with. The cosine cubed 2x, I'm going to rewrite that as, I'm going to introduce the sine squared and replace the cos squared with the sine 1 minus sine squared. And what that allows me to do is a substitution. As for the cosine squared 2x, we're going to use another substitution for this. And we're going to just use the exact same identity here. Instead of dealing with the cos squared x, we're going to now make the identity for cos squared 2x. And the cos squared 2x is, we can just replace this cosine expression. Let me just move this down a little bit. The right-hand side of that expression, all we're going to do is make that, instead of going from x to 2x, we're going to make that go from 2x to 4x. And that's the exact same expression in the double angle form, but instead of 1 and 2, we're using 2 and 4. And that's what we're going to use to replace this cos squared x here. And that's going to get rid of the power on the cosine. So I'm just going to continue on here. So we have our 1 over 8 integral. This is going to be written as cosine squared 2x times cosine 2x. Okay, so that's going to be the same as cos cubed plus 3 times, and instead of cos squared 2x, we're going to use cosine of 4x plus 1 all over 2. And now I have an expression that I can now integrate because that's no longer power on the cosine. We end up with 3 cosine 2x. This is already something I can integrate, plus 1, which I can integrate. And so we have that here. So I'm going to do a couple things in this next step. I'm going to just group together the 3 times 1 over 2. That constant, I'm going to combined with the plus 1 over here. Okay, the other thing I'm going to do is, in the yellow, I'm going to replace that with 1 minus sine squared. And that's going to allow me to, first of all, generate another cos 2x when I expand that out. And I have a sine squared 2x, cos 2x, which I'm going to be able to use substitution to solve. So here this becomes 3 over 2, and there's my cos 4x. That can be integrated. I have a plus 3 cos 2x. That can be integrated. And plus 1, that's going to be really 3 times 1 over 2 plus 1. So it's going to be 3 over 2 plus 1. And so that's going to work out to be 5 over 2. And I've grouped my constants, my constant terms, I got grouped all together now. And I got them all from the red parts here. Okay, so this next step here, I'm going to expand out these brackets. So I end up with 1 times cos 2x, and then minus sine squared 2x cos 2x. Okay, now I'm going to isolate that because I'm going to use substitution on this part here. Plus 3 over 2 cosine 4x plus 3 cosine 2x plus 5 over 2 dx, and I'm just going to combine these terms together as well. So this and this are going to combine to the next step. So I have 1 over 8 cosine, and I'm maybe going to split some of this up. So I'm going to make the sine squared 2x here and cos 2x. I'm going to do that as a separate integral plus 1 over 8. And I'm just going to group together a few things and then anti-differentiate that. Okay, so maybe I'll use an extra step here. I have 3 over 2 cosine of 4x plus I have got 1 cosine 2x on the left and 3 on the right, so I'm going to have 4 cosine 2x plus 5 over 2 times dx. Okay, so I can, in the red here, I'm going to do a substitution. So I'm going to let u equal sine 2x, and that makes du equal to 2 cosine 2x. So sine 2x becomes cos 2x, and then make sure we multiply by 2. So I'm going to replace the cos 2x dx. I'm going to replace this portion here. Let me just highlight that. This portion here, I'm going to replace with this du. And so my integral will be negative 1 over 8. I'm going to end up with u squared, replacing the sine 2x, and the du, I'm going to replace I'm going to replace the cos 2x dx with the du divided by 2. So that 2 has to come out on the outside. And that can be integrated. I'm going to integrate this expression here, the next parts of this. So I get 3 over 16, and the cos 4x becomes sine 4x. And then I have to divide by 4, so I'm going to get rid of that there. I'm going to divide by 4 plus, this is going to be 1 over 8. So it's going to be 4 over 8 sine of 2x. And then we're going to divide by 2. And then plus 5x over 2 plus c. Okay, so that's all been integrated in black. I just have to deal with the coefficients. In the red over here, what I'm going to do is I'm going to finish off that integral. So this becomes negative 1 over 16 u cubed over 3. And then we're going to back substitute for that. And then the rest of this is going to be plus 3 sine 4x over 64 plus, this is going to simplify to sine 2x over 4 plus 5x over 2. Oops, and I have to make sure that, in fact, I have forgotten about this times by 1/8 over here. Okay, so this is, I should really clean that up. That 1 over 8 came from over here. This 1 over 8, I forgot to expand it and onto the constant 5 over 2. So this becomes 5x over 16 plus c. Okay, and then the last part here, we're going to back substitute. So we end up with negative sine cubed of 2x. And that's going to be all over 48 plus 3 sine 4x all over 64 plus sine 2x over 4 plus 5x over 16 plus c. Okay, and there's my final antiderivative answer. Now this is quite complicated. This is a lot of stuff going on here. We use trig identities. Okay, we used some substitution in here. We had to make sure we kept track of our coefficients. Okay, there's lots of fractional coefficients in here, so there's lots of places where we can make mistakes. So we have to be extra careful when we're integrating this. And this would represent a very difficult integral to have to do.